Well, welcome. Today we're going to be kind of talking about this idea of our fractions, our decimals, and our percents, and really the truth of how they are equivalent, right? They're equivalents of one another. It's really cool. You can start to see how something can be a fraction, which also creates a decimal, which also creates a percentage, and how they are so related. And we're just going to walk through this thing, kind of look at it, see what it means, break apart each one of these pieces, and then kind of see like where do they connect, right? So as always, I will go over my favorite, close to favorite, I don't know, maybe my absolute favorite word in math, and that is the idea of equivalent. If you watched videos before where we're using equivalence, then you know exactly where I'm going with this and what I'm going to say, but I'm going to do it anyway. So equivalent, right? This concept of something that has the same value, but it looks different. And we see that everywhere. We can see that with whole numbers where like 3 is also equal to, I don't know, 5 minus 2, right? We're on both sides of these equal signs, both sides of the equal side. You have the value of 3, but this side looks different, right? 5 minus 2 looks different than 3. That's equivalent. They're equivalent. You could think about it in terms of fractions. We've talked about equivalent fractions. Let's say I have 1/2 of something, right? So if I have 1/2 of something, and then I create a equal model and partition that differently, I now see that I have 2/4, and these are equivalent, but you can see they look different, right? This is 1/2, this is 2/4, but they have the same amount. It's the same amount of shaded, right? So that is that concept. I think the other one I always love to say, and then I'll just move on my merry ways, we nail this one down again, is that idea of money, right? A $1 bill is the same thing as 4/4. Exact same value if you go into the store with 4/4 or if you go into the store with a dollar bill, they're the exact same amount of money. You can buy the same things with them, right? So that's where we're at, equivalent. Same value, looks different. And that is totally true for thinking about fractions. Wow, let's try that better. Fractions and decimals and percentages is that they will all be the same at some point. They'll just look different. So let's just kind of start right away. One thing we've talked about with decimals, I'm going to start there, is that there are 2 major place values that we've really looked at. We've looked at the tenths place and we've looked at the hundredths place, right? Whoa, hundredths. So let's go explore that real quick. So decimals, we'll come back to that chart. So decimals, we've talked about the tenths and we've talked about the hundredths. And the reality is, if we just look at decimals, we can just read them based on these place values, just plain and simple. And that's how we read decimals. And if we can read a decimal, we can write a decimal. If we can read a decimal, we can also write it as a fraction. And that's what I'll talk about here. So we have like our ones place, and then here's the tenths, and here's the hundredths. And whatever decimal we have, we just read the number and that's what we get. So for example, if we had this here, right? You can see I have nothing in my ones place. So I just have to look at what I see, and what I see is 3. And that 1 is in the tens place, so I have 3/10. That's what this says. That's 3/10, right? Or if we had something like this. Again, I have nothing in my ones place, so I'm looking at reading just the number I see, which is 67. Right, this is 67. And then the last place value that's being used is the hundredths place. So this is 67 hundredths. That's how I would read that. Now, I'm reviewing this and talking about this because this is really what's going to help us think about how we convert things into equivalent fractions. So let's go back to this. I'm going to get rid of this now. It's kind of messy. But I'm going to put in some decimals. And then what we can do is let's just start thinking about, like, what does it say? And then that tells us it's fraction. So here we go. Here's 3/10, right? I have 3 in the tens place. 3/10. 3/10. Oh, well, what does that say? What's a fraction that says 3/10? 3/10, right? There's that piece right there. There they go. Equivalent. So again, if we read it, we can write it as a fraction. So let's go here. What does this say? Well, if we read that, we would see we have 56, and then we're looking at the last place value. So we have 56 hundredths. Let's change the colors here so we can see. So this was, we'll keep this yellow. This is 3/10. So this is 56 hundredths. Well, what did I just say? I said 56, and then I said hundredths. So that's a denominator of 100, right? I said tenths here, so is a denominator of a tenth. So I hope this is already starting to click. Let's look at another one. Let's say we had this, right? So if I read what I see, if I read it, I can write it. And what I see is a 7. And then what's the place value? Hundredths, 7 hundredths, right? So that would be like right there how we make this equivalent between decimals and percentages. If you can just read it, you can write it. So, or fraction, excuse me. So what does that mean about percentages, right? So let's explore that, and we'll come back to this chart in a little bit. I'm gonna skip past here, and let's kind of talk about percentages. Well, percentage means of 100. That's what percentage means. When we're looking at percentage, we're looking at, like, what is the total out of 100? Because 100 is everything. 100% is all. That's why I often laugh when I hear athletes say, oh, I was out on the field and I gave 120% today. Well, actually, you can't. You can only give 100%. 100% is all of it. It's the max. It doesn't go much higher than that. There are some cases that you can look at statistically, things that are over 100%, but the reality is that all of one thing is 100%. That's the total. That's it. That's the max. And that's what a percentage is. So if we think about that, we're always kind of looking at, well, what is the percentage of 100? We always relate it to of 100. So let's use like an example of a fraction, right? We have 56 hundredths. Oh, well, if I wrote that as a percentage, that says 56 hundredths. And if I think about this again, and I can look at it either way, right? There's a few tricks, but let's just use the fraction in this case. If I look at this fraction, well, this says 56 of 100. Of 100. It says 56, like 56 of, because there's that fraction line, of 100. Of 100. So if 56 hundredths or 56 hundredths or 56 of 100, that just means I have 56%. That's pretty simple. If my denominator is already 100, right? If it's already 100, oh, there's so many things being underlined. Let's clear that. I'll change some colors. This is already out of 100, which means then I can just take my numerator and call it a percentage. That's 56%. Another cool trick is if I have a decimal, I can just ignore the decimal and write that as a percent, because that's what it is. It's 56 hundredths or 56% or 56 of 100. So that's kind of where we can make these connections. So let's play with that a little bit. I mean, I know that was quick, but like, let's look at what this says. Well, the first one, let's see, we'll do this in a different color. The first one doesn't say of 100, right? So we're gonna have to talk about that. We'll come back. But this one here, it does say 56 of 100 or 56. That's 56%. Because percent means of 100, right? So then let's look at this one. This says 7 of 100, right? So, well, 7 out of it, that's just 7%. But if we look at this first one again, you can see we have a discrepancy because this doesn't say of 100. It doesn't. So what do we do? Let's jump over a few screens and see. What should we do? Wait, I gotta jump back. What was it? 3/10? Okay, let's go. Here we go. All right, so we had 3/10. Now, one of the things I said, and this is where we can create this equivalent, right? I can use a fraction to make a percentage or to make a decimal, right? That's all those things I can do. So I said, again, this needs to be, well, let's try it two ways. Well, let's go with the 100. We said percentage is equal to of 100. Okay, well, let's make an equivalent fraction, right? Let's make this of 100. Well, what do I need to do? If I needed to take this 3/10 and I made an equivalent fraction where the denominator said of 100, well, I could say, well, what's 10 times 10? Yeah, that's 100. And if I multiply my denominator by 10, and you'll see this in a video, I can multiply the numerator by 10. Maybe you've already seen this. That equals 30. So now this says 30 out of 100, which would then be 30%. And if it was a decimal, it could be this. It could also be, when we talked about equivalent decimals, this. They're all the same. So that's where we can think about when we have ones that do not say out of 100, we can make it out of 100, or we could also just look at our decimal. This says 3/10, that says 3/10. Well, then I just have to say, oh, well, then that's 30%. 30, because remember, it's in the tenths place, so technically I could have a 0 here. So this is kind of what it looks like with fractions, decimals, and percents. I'm going to do this really quick because we only have a limited amount of time, but let's look at that one more time with some other ones. So we have a fraction, we have a decimal, we have percent. So again, let's think about what all this means. If we read it, we can write it. So let's write a fraction first. Let's say 7/10. Okay, that says 7/10. Well, 7/10 as a decimal looks like a 7 in the tenths place, 7/10. And what does that look like as a percentage? Well, one of the tricks was I could look at this out of 100, make an equivalent fraction, or I could literally just look at my decimal, ignore that decimal, and realize that this is a 7 in the tenths place, so that would equal 70%, right? Okay, so I don't know, 81 hundredths. Again, if I read it, I can write it 81 hundredths. That means I have 81 and 1 is in the hundredths place, 81 hundredths. And if I want to make a percentage, I can just ignore that decimal, 81%. And let's do one more where, again, I think it's to remember, let's say like 300ths, okay? So let's look at that. That's 300ths, so that would be nothing in the tens place, a 3 in the hundredths place. And then if we ignored everything and just called that a percentage, that would just be 3%, right? Because once we ignore things, once we ignore that decimal, we can kind of treat that like a ones place, okay? All right, I tried to run through that just to make some connections. So I hope this helps with the idea of how fractions, decimals, and percentages are equivalent. We'll look further into this. There'll be more information around that, but for now, there's just a quick introduction. So thanks for your time. As always, thanks for your hard work, and we'll see you really soon.